Hello everyone, welcome to my channel Math 6 IT Academy. In this video, we are going to learn about the circumcenter. So, circumcenter. So, circumcenter means the point of intersection of the perpendicular bisectors is the circumcenter. So, first of all, I am taking a triangle ABC. Okay, and now draw the perpendicular bisector for all three sides. So this is the perpendicular bisector and it is bisecting and also making 90 degrees. And similarly, this you can take as E and here this is F. Okay. So now this is the perpendicular bisectors. These are and these perpendicular bisectors are intersecting at one point. In that point we take as C and this is the circumcenter. Okay. So here when you have the vertex of the triangle x1 comma y1 and x2 comma y2 and x3 comma y3, then circumcenter C is equal to, or circumcenter is equal to x1 sin 2a plus x2 sin 2b plus x3 sin 2c divided by sin 2a plus sin 2b plus sin 2c, comma y1 sin 2a plus y2 sin 2b plus y3 sin 2c divided by sin 2a plus sin 2b plus sin 2c. Okay, so this is the formula to find the circumcenter. Okay, so now here in the case of right triangle, when you have a right triangle ABC, right angle at B, what is the circumcenter means? Here we have to draw the perpendicular bisectors for the sides BC, AB and also AC. So this is the perpendicular bisector for the BC and here for the AC and for the AB. So these perpendicular bisectors are intersecting at one point and that we can identify as C. Okay. So this is the midpoint. Better here you are when you have confusion you can take this C1, ABC1 and you can take this C, or you can take triangle PQR. Better. Then here C is a circumcenter. So here C is a midpoint of the hypotenuse. Okay. So in right triangle, circumcenter is the midpoint of the hypotenuse. So whenever the vertex are given to you, first of all we have to check whether with the given vertex can we form the right triangle or not, means not that we have to find. So if with the given vertices we can form the right triangle, then we can find simply the midpoint of the hypotenuse, hence that is the circumcenter. If not, when the values of given ABC and also the angles are given, then we have to use this formula. Otherwise, if only the vertices are given, we have to use that this C is equidistant from the all the vertex. Here also you can take the C1 instead of C because here we have already taken this as C as a circumcenter. So here you just write one point before it. Circumcenter is equidistant from the angular points. Angular points means here ABC. Angular points. That is here AC is equal to BC is equals to CC1. Okay. So here we can use the distance formula and we can find simply the value of C or circumcenter C. Okay. So these are the ways of finding the circumcenter. So next we have orthocenter. the point of intersection of altitudes is called orthocenter. So here A, B, C is triangle, and altitude means here always it's make 90 degrees to the base from the opposite vertex. Again I am telling, altitude means it is a line segment from the opposite vertex to the base and makes 90 degrees to the base. This is the altitude. So like this we have to draw the altitudes for the remaining two sides, and these altitudes will intersect at one point, and that is only the orthocenter. So point of intersection of altitudes is called orthocenter. Okay, so here how to find the orthocenter when the vertices is given? x1 comma y1, b is x2 comma y2, and c is x3 comma y3. Okay, so orthocenter ho x comma y is equal to here x1 tan a plus x2 tan b plus x3 tan c by tan a plus tan b plus tan c, comma y1 tan a plus y2 tan b plus y3 tan c divided by tan a plus tan b plus tan c. Okay, so this is the formula to find the orthocenter. So in this we must have to know all the vertices ABC and also the angles ABC. Okay, and after simplifying, after substituting all the values and simplifying, you will get the orthocenter. So this is the formula. So next here, if it is not given to us, then of course we have several ways. Here one more important key point we have to remember here. The centroid divides orthocenter and circumcenter in 2:1 ratio. Okay, so this we have to remember. So centroid means G divides orthocenter and circumcenter in the ratio of 2:1. Okay, so if you want to find out the orthocenter, it is very easy to find the circumcenter and also centroid, because we have the circumcenter means here it is a point which is equidistant from the angular points of the given triangle, and also centroid means here we can find simply by adding all the x coefficient divided by 3 and also y coefficient, means here x1 plus x2 plus x3 by 3 and y1 plus y2 plus y3 by 3. Okay, so here by that we can find G and also C, and after applying the section formula there is a chance of getting O here. Of course it is a time taking process, and we have one more process also there to find the orthocenter by using the slopes and also straight line equations. So that to if you want to use that we need basic knowledge. So now I will explain that. So after explanation of the slope and also the straight line equations, once again we will discuss about the orthocenter and ways of finding orthocenter easily than these methods we will discuss in future classes. Okay, so here these are the important points in the orthocenter. So here when you see the orthocenter in the case of right triangle, here I am taking a right triangle. Suppose here ABC and right angle at B. Okay, so here ABC means here AB and BC both are the perpendicular, and here we need one more perpendicular, and that is from the hypotenuse. So this perpendicular is intersecting what here means at B. So in a right triangle where the orthocenter will locate, in the sense the vertex at right angle is nothing but the orthocenter in the right triangle. Okay, So this is also one of the important points. Once again I am repeating, orthocenter for a right triangle is right angle at the vertex is the orthocenter. So for example, ABC triangle, angle B is 90. So here angle B is only, means the vertex B is only the orthocenter for the triangle ABC. Okay. So one more important point I want to share with you all. So here, if the vertices are like this, if A is alpha comma alpha, B alpha comma beta, and C beta comma alpha. If the vertices are like this, then orthocenter is alpha comma alpha. This is the very important point. So here, why alpha comma alpha we are getting as the orthocenter? So that we will see now. So simply to identify this, I am finding the distance between the AB. Okay. So here AB means here what? Here distance between the AB means here square root of AB square, you can write. AB square is equal to what here? Alpha minus alpha whole square 0. That means here alpha minus beta whole square only will come. AB square. And similarly find the BC square. So BC square means here it is what? Alpha minus beta whole square plus beta minus alpha whole square. And this can be written as what? 2 times of alpha minus beta whole square. This is the BC square value. Okay. And similarly find the another, that is AC square. AC square means what here? AC. Here alpha minus beta whole square plus alpha minus alpha. Alpha minus alpha means here 0. So that's it. So what we can understand with this means here 2 times of alpha minus beta whole square is equal to BC square, and these two are equal. So by these two, so by above equations, what we can write means here, this BC square value is equal to AB square plus AC square. So that means what? It's forming a right triangle. It's forming a right triangle. Suppose here ABC, when you are taking this AB square plus AC square. So here A, BC. So here AC square plus AB square is equal to BC square. BC square is a hypotenuse and AB square plus AC square, it is forming a right triangle, and right angle at A. So just now only I have given the third point. When we have a right triangle, then the orthocenter is the vertex containing the right angle. So the vertex containing the right angle is A. A is nothing but alpha comma alpha. Okay. So in simple words, if you remember like this, means alpha comma alpha and alpha comma beta and beta comma alpha, then you just directly take the answer as alpha comma alpha is the orthocenter for the given vertex, for the given triangle. Okay. So that's all about the orthocenter. So next we have one more important center for triangle. That is 9-point circle. 9-point circle. So 9-point circle. That means if a circle passes through the 9 points, is called 9-point circles. So here we see here if a circle passing through. So what are the 9 points I will write now first. If a circle passing through the feet of the perpendicular. Feet of the perpendicular. Okay. So let me draw the diagram. With the help of the diagram, let me explain here to you. So here I am taking a triangle ABC here. Clear, right? Feet of the perpendicular. Feet of the perpendicular means here first you draw the perpendicular here. That B perpendicular and E is perpendicular, and of course CF is perpendicular. BD CF. And circle passing through the feet of the perpendicular means here DEF. That must, the circle must pass through these 3 points. And and the medians of the sides of the triangle, that is BC, AC and AB. So midpoints. So midpoints means here what? Suppose here A, B, C, D, E, F. So H, and here I will take J, and this is the median, and here K you can take. Okay, these are the medians. Means here K is the midpoint, J is the midpoint, and H is the midpoint of the sides of the triangle. And the midpoints of the line segment joining the orthocenter to the angular points. So midpoints of the line segment joining the orthocenter to the angular points. So first orthocenter. Orthocenter means point of congruency of the altitudes. So here this altitudes already we have run, and these altitudes are intersecting in one point, and that is the orthocenter, and we will denote by O. Right? So now the line segment joining the midpoints of the orthocenter to the angular points. Angular points means the vertices of the triangle ABC. So here OA midpoint of the OA, suppose you can take this here already H, JK you can take it as L, and midpoint of OB you can take it as M, and midpoint of here OC you can take it as suppose N. Okay, so if the circle is passing through all these 9 points, then the circle is called 9-point circle. Okay, so now you just draw the circle which is passing through the points. Okay, so this is a circle which is passing through the 9 points. Okay, so these are the 9 points totally. How G, E, F. Here first D, E, F. These are the feet of the perpendicular. And next midpoints. There are have taken H, J, K. Why I didn't take G? Means G is a centroid, I means in center, so only I didn't take it. So here next H, G, K, these are the medians. Next midpoints of the line segment joining the orthocenter to the angular points. They have taken as L, M, N. So these are the totally 9 points. Okay. So here this is about the 9-point circle. Okay. So now here we have some important points here. So here this radius of the 9-point circle is equal to 1/2 of the radius of the circumcircle. Okay, radius of the 9-point circle is equal to half of the radius of the circumcircle. And also this O means here this 9-point circle, 9-point circle center, the center of the circle is midpoint of the O and C. O and C means orthocenter and also circumcenter. So is the midpoint of O and C. Okay, so these are the important points for the 9-point circle. So here one thing you have to understand, in any triangle, this circumcenter, centroid and orthocenter, incenter will lie on the same line. Means all these points are congruent points. Here collinear points are these points. Okay, so that you have to remember. So that's all about the different centers of the triangle. So thank you for watching. Thank you all.